The learning outcome for these sessions will be adversarial thinking in networking, the weaknesses in networking, the exposure, eavesdropping, the security groups, control, access control lists, etc. The protocol stacks and network devices. Okay, we will formally introduce the OSI stacks and the different protocols and the devices of each layer. Finally, we will talk about tools, the physical tools and the software tools. This is a brief table content for today. We're going to go through the OSI layer and the peer-to-peer networking. Then we will introduce the network devices, and then we will talk about network and internet. And the next one we'll talk about network addresses, and finally we talk about network tools. Now let's dive deeper into the layers of the OSI, Open System Interconnect model. This model, established in 1984 by the International Organization for Standardization, or ISO, this framework is standardized the functions of a communication systems and mostly used for designing, implementation, and understanding of network architecture and protocols. All the 7 layers have their own functions and responsibilities, which simplifies the process of troubleshooting network issues. We will go through the individual layers in the subsequent slides. You can use this acronym. Please do not throw sausage pizza away, to help to remember the name of the layers and their orders from the bottom up. Okay. Now let's go to the OSI layer by layer. Now from the bottom we have the layer 1, or we call physical layer. Now this is where we transmit the raw data over the physical medium. And this is where all the wires, cables, and plugs, this is where all they reside. Okay, so this layer specify the voltage, the frequencies, and how this cables need to be run, need to be connected, and so on, right? And also how the data are being represented. The ones and zeros, how are they represented in terms of the volts? Okay, some of the cables require them to be running at like 5 volts and 0 volts, and some will be at some other voltages and so on. So this is the physical layer where we specify the physical property, okay, of the data connection. Now the next layer is where the abstraction comes in. This is the data link layer. This is still physical because the data link layer is where you connect to the physical device and it connects to the intelligence, the software, right? So in a more technical terms, this is where the device drivers are. Okay, this is where the cable plug into the devices, be it a PC or a router or a switch. Okay, this is where the actual interconnection comes in, the data link layer. And you also specify the kind of frame, or the kind of, because in the data link layer we talk about frame. Okay, it specify how the data is being structured before it being passed into the physical layer. So this is the data link layer is a very important layer because it is where the hardware meets the software, right? Now, the next layer up from the data link is what we call the network layer. Now this is a layer that defines the path. Okay, so we already connected to the hardware, we connect to the cable. Now we need to specify how the data moves along the path. Right? So the network layer is where we specify the interconnectivity between machines, right? So this is a network layer, right? So this layer we decide the route for the message to take, right? And the some of the protocols that define what we call the route table are working within this layer, right? The network layer. The next layer up from the network layer is the transport layer. Now the transport layer is where we define the communication between the machines. Now what do we mean by that? The transport layer define how the messages are being treated. Is it being treated as a channel? Okay, this is also where the data correction are being defined. Whether do you want to have data correction or do you don't want to have a data correction, right? It is defined here in the transport layer. Okay, we call it the transmission protocol, right? So you define you could potentially have what we call a connection-oriented protocol that is defined on the transport layer that construct a channel or session, right, between two network devices. Okay, and then the data that flow through this channel or these sessions can have error correction, meaning if any one of the data is missing or some error creeps in, it will self-correct. It doesn't need to involve any other layers. Okay, within this layer, they can handle the error correction, right? Now, on top of transport, we talk about session, right? Session is where you maintain kind of like a separate channel between one machine to another, and you can have multiple sessions between two machines, and each sessions doesn't interfere with each other. Now, when it boils down to the physical layer, okay, the data could be intermixed to each other. That means the first packet of the first sessions comes in, and then the first packet of the second sessions comes next. Okay, on the data channel, you may seems to be all jumbled up, but as you reach the fifth layer, all are separated into the individual sessions, right? So this is what we call a sessions connections. Okay, now the next layer up from the session is called the presentation layer. Now the presentation layer ensures that the data is in a format that is usable and it can be manipulated or exchanged or translate between one presentation to another presentation. I mean, between it could be this presentation could be encryption. Okay, it could be between two different languages. It could be between two different encoding systems. Right, so this is what we call the presentation layer. Is where it finally, before you give this data, okay, you need to encode it somehow, right? So this is what we call the presentation layer. Now the next layer is called the application layer. The application layer is where the actual usage of the data is. Okay, this is where it resides. Okay, this is where the data has been given a use, some usage. Like for example, a text or file or a book could be sent across as pictures, could be sent across as text, it could be sent across as sound, for example. So, and the application, like for example, you could have a Kindle reader on the other end, which is transmitting a file, data from the server, from the let's say for example the Amazon server, okay, and it take this data, which is a book for example, and then it send across the network and reach your Kindle devices. In your Kindle devices, display it to the user, or play it as a sound file to the user. Right, so the application is the one that gives usages to the data, gives usages to the connectivity. This application could be your Facebook app, it could be your Twitter app, it could be your browser, it could be a HR application, and so on. So this the possibility is endless, right? But this is where the internet gains the multiple usages, and it's where it balloons, right? So this is the application layer. Now, the next thing we talk about will be peer-to-peer networking. Now, what does it mean? This peer-to-peer means that on two machines, okay, you can see two machines on the left and on the right, right? Each have 7 layers, okay, all the way from the physical data link, network, transport, sessions, presentation, application. The application layer will talk to the application layer, the presentation to the presentation, the transport to the transport, network to the network. You don't have one computer, or you don't have one machine or devices where the application layer talks to the transport layer. No, it doesn't work that way, right? It doesn't talk to non-peer. The peer is the same layer. That means you only talk to the same layer, right? So when the data is being transmitted from one machine to another machine, it goes down. It goes from the topmost layer, layer 7, all the way down to layer 1, and then it push through the physical connection, and this physical connections is reach the destination, and the destination goes up, right? So a data would be transmitted from the application to the presentation, session, transport, network, data link, physical, and then through the physical medium, pick up by the destination physical layer, and then move up, data link, network, transport, session, presentation, and then finally to the application. And to the individual layer is as if each layer is talking to the corresponding layer, right? This is what we call peer-to-peer networking, right? So from the top layer down to the second layer, we call it encapsulation. Now, encapsulation is when you wrap around the header and the footer and, over the payload. You can see over here, this is what we call payload. Okay, so you wrap around the header and the footer, and the payload is actually what we call the data from the higher level, right? So we have the end level, the end layer, having the end header and the end footer, okay, and together with the data from the previous layer, okay, and this is what we call the payload of the next layer, right? And if you think about it, and when you go to the n-2, okay, this whole thing would be the data. And this whole thing will be the data. Okay, will be the payload of the n-2 layer. Right? So this is what we call encapsulation. We add header and footer, which is the information required for the particular layer, and then we move it to the next layer. Right? And in next layer will add their own header and footer. Right? And so from the bottom up okay, we strip off the header and the footer and pass the data or pass the payload up to the higher level. We call this decapsulation. Okay, decapsulation. D means take away. Right? Now, we also need to probably introduce a separate layer model. We call it the TCP/IP layer model, which you may heard about from some other places. Okay. Now the TCP/IP model has only 4 layers. Okay, the application, transport, internet, and then network access. 4 layers. Now it actually corresponds to the OSI layer. Very simply, the application layer actually refers to the top 3 layers of the OSI. The transport refers to the transport layer of the OSI. The network layer refers to the network layer of the OSI. The network access is the bottom 2 layers of the OSI, which is the data link and physical. Right? Now, in one way, the TCP/IP model is very closely represent the internet as it is today, because internet is really dominated predominantly from these 2 protocols, the TCP protocol and then the IP protocol. Right? These 2 protocols dominates probably 90% of all the packets that is being flowing around internet today, right? And the TCP/IP layer, okay, in a nutshell, is how the current the real world operates, right? The bottom 4 layers is very, very what we call accurate representation, and the top 3 layers, a lot of times we don't implement the sessions and the presentation layer as a separate layer. We kind of like squeeze everything together, and the application actually take care of everything. And the application will do the session management. The application also do the presentation of the data itself, right? And so, in a sense, the TCP/IP layer is a very much more realistic. However, the OSI layer is a preferred model because it is very distinct, and it allows us to model the way the data moves. How the data is being transmitted, and it is now the kind of very de facto standard that people in the networking area refers to the OSI layer when we talk about, oh, do you have a layer 3 protocol? What's the layer 3 protocol? Or what is the layer 4 devices that you have, or the layer 3 devices that you have, or and so on, or layer 2 addresses. So a lot of time when we refer to layer, we are actually referring to the OSI layer more often than the TCP/IP layers.